Okay, so let's try. Yeah. Let's continue, guys. So for example, I want you to select only the first column. Okay, so let's call this J2, and J2 is going to be only the first column of J. So what we do is all rows, first column. You see that? So remember, the first part, the first argument is going to be rows, and the second one is the columns. So if I want all the rows, only the first column, we do this. Then you get this one. Okay, so now guys, imagine that you want the first column, the third column, no, sorry, the first, the third, and the fifth column. How do you do that? You can use a sequence, right? Because it's the first, the third, and the fifth. How do you do that?
You can go ahead and declare J3 equals to J, and then declare all rows, which is the semicolon, and then comma, and then go from 1, stick a 2 in the middle, and then 5.
Do you agree with that, guys, or not?
No,
so
actually,
it says 1, 3, 5. Yes, it says basically all the rows. So all 1, 2, 3, 4, 5. And then the columns that I will select are 1 plus 2, 3, this column, and this column. Oh. Oh, yes. Sorry, guys. When you address something, it needs to be like a vector. Got it? So what I've said is all rows, columns 1, 3, and 5. And then you get this. You can take a look to J, 1, 3, and 5. Are these ones here. Make sense? Okay, so now let's go take a look to J. Now you can do what I was telling to you. So I want this column to be the first column, this the second, the third, and the fourth. So basically flip. So let's call this J4. Ready? So how can you change J? So the columns are going to change or not? So remember, first of all, let's define the columns are going to change or not. So do I want to shift columns? No, I want the columns to be the same. So all columns. The things that I want to change are the order of the rows, right? So I want to shift it, right? So according to what we have done, guys, what can you do? I want the fourth row to be the first, the third, the second, etc.
You reshuffle a position, you declare J, and then you go from 4, which is the row number 4, go back up to, so stick a -1 in the middle, and then declare 1, which is effectively flips it, and then goes by -1 increment.
Yeah, do you agree? So what this is going to do, guys, is going to be for the fourth row, all the columns, then the next one, the third row, all the columns, the next one, the second row, all the columns, etc. Make sense to you guys? Do you understand this one here, guys? These are crucial things that we're going to use in data management later. Do you understand?
Professor, you forgot about the bracket.
Yeah. It needs to be declared like a vector. Take a look. Make sense, guys? Okay, so you now do J5. It's also going to be based on J. But now what I want is the 88 to be the first one, the 5, the second, etc. So what I want to do now is the shift from right to left. Okay, 2 minutes to do that. Based on J, okay? Guys, what I will request from you is if you can review this material and just try to do what we have done, okay? Just to start, training your brain. Since it's training, it's only training. As I mentioned before, on Friday, I will give you another video and then some exercises for you, and then we discuss them on Monday. Ready? So we can move. So J is going to be equal to what? So now what I want is to keep all rows, right? right? I'm not changing the rows. What I'm changing is the columns. So how do I do that? I want the last column. How many columns do we have? We have 3, 6, right? I want the last column. So column 6 to be my first column. Then I want to decrease by 1 up to 1. Guys, do you agree?
Yeah.
Bracket, professor, bracket.
Yeah, well, no, in this case, I am not doing any type of operation. It works, you see? In general, guys, yes, in general, what I suggest you always to do this, because sometimes, sometimes it gets crazy. Make sense to everyone? Okay, so now, imagine that you don't know the number of in this one here. How you can use the size command instead of 6? Because this program here is going to be very specific to having one matrix that has 6 columns, do you agree? But you want to create something that is more flexible, okay? If you have 6 columns, it's able to capture that. If it has 8 columns, it's able to capture that. How do we do that? What do we use instead of 6?
And?
Yeah, this can be one. Okay, this is one way. And how, if you don't want to use n, you want to use size, what do you use? So remember, size, guys, always provides you number of rows, number of columns. So which one are you going to use? Size 1 or size 2? Two, because remember, size comma 2, size j comma 2 implies tell me the number of columns. So these 2 represents columns of the matrix J. Correct? So this is more technical, guys. So this, if you change the data, this is going to be able to do that. If you write 6, you're going to be always, forced to use a matrix that has 6 columns. When you use these type of things, no, you can have 5, 7, 8, whatever columns you want. The same can happen with the previous one. Where's the one that we use the rows? Now, this one here, right? So instead of 4, I can use size of j comma 1. Make sense to you guys? This one here is more flexible. Guys, what we try to do is we try to create something that is flexible, okay? That you change the data, your code remains the same. That's what we're going to be working towards, guys. Make sense? Questions? Let's do a couple more things and then we'll stop here. Yeah. So let's define A. Remember A and B. So array mathematics, guys, that is basically linear algebra, the basic of linear algebra. So you can do A plus B because both of them have the same dimension. Got it? So remember how many of you have taken linear algebra? Guys, yeah, Kevin, what about Jameson? No? Matrix X, have you worked with Matrix X, Jack? Okay, perfect. Yes, that's linear algebra, the basic point of linear algebra. Ryan, have you done that? Matrices, vectors, etc. Have you done that?
I think so, yes.
Yeah, so we're going to do a review later. Hey, Jack, you did it or you had a question?
I had done it. I think there's a lag in my video.
Perfect. Okay, excellent. Okay, guys, so you can do that. However, what happens if you try to do A times B? I have an error, okay? Because there are some dimensions, specifications that you need to satisfy. I will do this next class. However, what you can do, guys, is something that is called element by element multiplication. Okay, so if you do A times B, so take a look to what happens. So where's A? So you do element by element. 1 times 12, 12. 2 times 20, 2 times 13, 26, etc. So this is element by element. Agree? You can do element by element power, for example. So these are huge numbers. You see that's e to the power 11. So these are enormous numbers. Okay, so this is what is called element by element operations, guys. You can also divide element by element. This dot here is a mathematical representation of element by element. Oh, what I did. Makes sense? Now, a couple of other things, and then I need more time for doing more stuff later. But in any case, so let's assume, guys, that I have my A. This is my A. It's a row vector. Do you agree? How do I transform this row vector into a column vector? So basically from here to here. What I can do is basically, let's call this A1. I can use a command that is called Beck. I don't remember if Beck is here. No, we don't have Beck in this one here. Well, in any case. What I can do is simply A transpose. So the tilde, this one here, helps me to help me transpose the vector. And if you want to go back again, you simply transpose again. Make sense? Now, guys, what was my big vector? Yeah, J4. There is another variable that we sometimes use. I don't use this a lot, but sometimes it is good for you to know. The command that is called length of J4. So what it does here, guys, it tells you what is the maximum of the rows or columns. Okay. So in this case, 6. The only issue is that you know if it's columns or rows. But length gives you the maximum of the rows or columns. Now, if you want to know how many observations do you have, what can you do? So I mean, how many observations I have 4 times 6, 24, right? How do I find that? You can use a command that is called prot and size of j, for example, or this is size of j4. So prot, guys, multiplies the elements that are in between. So remember, say a size j4 is going to give me the number of rows, number of columns, right? So it's going to be 4 and 6. And if on top of that I put prot, multiply, so it's going to do 6 times 4, 24. Right? So this is one of the uses of prot. So it's basically, you always want to know how many observations do I have in total? Okay, number of columns times number of rows. So you do prot size of j4. Now, another thing that you are able to do is how many dates. Normally dates are rows. So you know size 1. How many individuals do I have? Normally individuals go in columns, size 2. Make sense, guys? Okay, so can you please review and try to make sense of all this stuff? Next class, I will do much more. We're going to do a lot of exercises and just to warm up. You need to be proficient in this part of the equation, guys. Okay, this is going to be the basic. This is the foundations, guys, of what comes later. Okay, what comes later, if you understand this part here, is going to be much simpler. Okay, guys, so we stop here today. I need at least 1 hour to do the next part. I will do this on a video. We do exercises and we solve on next time. Got it? Okay, guys. Anything that you need, if you have questions, please let me know, etc. All right, guys. Okay.
Professor.
Yes.
Real quick, did you say you wanted to meet on Monday at 5:30? Were you looking to
yes,
change the time of the class?
Yes, we started the class at 5:30. Please remember that. Okay.
All right, perfect. Thank you.
Got it? Perfect. See you guys. Have a nice weekend. Take care.
Professor, quick word.
Yes, Kevin.
So from this point
Wait,
on,
wait. I need to stop recording.